Thank you so much for joining me. In this video clip about acids and bases, we're going to clean up some of the terminology. We've come across this, but not explicitly defined some of these. In my previous videos, I wanted people to get a sense of the behavior and the definitions of acids and bases first. The first is something called amphiprotic. An amphiprotic substance can both accept a proton or donate a proton. So this is applying to our Bronsted-Lowry definition of an acid and a base. And water is a key example of an amphiprotic substance. So in this case, HCl, a strong acid, is going to donate to the H2O. So water is acting as a base. It is accepting an H and a plus charge there. Whoops. Here, ammonia, a weak base, is going to take an H and a plus. So in this case, water is donating an H and a plus charge. So it is being amphiprotic. Okay? Now, let's take a look at the next examples. Circle an amphiprotic. Amphoteric, I'm going to talk about in more detail in just a minute. Okay, so in this case, I have HPO4 2- acting as an acid and water acting as a base. So the HPO4 is donating. In this example, it's the water that is doing the donating. So water is acting as the acid and HPO4- is 2- is acting as the base. Okay. When you have, well, I'll talk about that in just a minute. Okay. Sorry, I was getting ahead of myself. Right. So this would make, I think, better would be to put H3O plus here, given the way I wrote these reactions. Now, amphoteric is subtly different. It is often used as a synonym. And in this case, rather than focusing in on the donating and accepting of H pluses, amphoteric talks about reactivity and acting as both acids and bases. What this definition does is it includes Lewis acids and Lewis bases. So we have this big set of substances called amphoteric that includes our Lewis acids and bases. A subset of those are amphiprotic. Okay, so subtle difference between those terms in Bronsted-Lowry, and that's what I'm focusing on at this point. I'll use those terms a little bit interchangeably, but technically amphoteric is a broader term than is amphiprotic. Okay? Now, there's also polyprotic. You could talk about diprotic, triprotic. Poly is many protons. So poly means many protons. So HCl is monoprotic acid. H2S is diprotic. So yes, it would be considered polyprotic, poly meaning more than one. HClO3, chloric acid, is monoprotic. So it is not considered to be polyprotic. H2CO3 is diprotic. So yes, it would. Now, if you look at phosphoric acid, it is called triprotic. It is a polyprotic acid. It is triprotic. And I want you to notice the in-between species that you would get, okay, with your phosphoric acid. Okay, each time I go through here, I'm adding an H and a plus charge. But you notice I have an end here and it ends here. The two species that are the in-between species can act as both acids and bases. Okay, so if you look at H2PO4, it can act as a base and accept an H and a plus, or it can act as an acid and donate an H and a plus. HPO4 can act as a base and accept an H and a plus, or it can act as an acid and donate an H and a plus. So those middle species are considered amphiprotic. Okay, so hopefully that terminology is clear. Okay, to be amphiprotic, it has to be able to accept and donate. H3PO4 can donate, but it cannot accept. PO43 minus can accept, but it cannot donate. Okay, so that's why these two species are not considered amphiprotic here. Okay. So that's some of our key terminology for acids and bases, and thanks for joining me. I appreciate it.